Hi, welcome back to the breadboard. Today is Tuesday, so therefore it is a TI day. And to continue the theme of Internet of Things, I wanted to share with you a board that I have, which is a Boosterpack Sensor 2 board. And the nice thing about this board is the quantity of sensors that have been provided on here. So let's not waste any time and let's go look at the board. So this is the board I have. As you can see, I have it plugged into a TIVA C series board. The reason for that is because the TIVA C series has the XL connectors. The other reason for that is because under Code Composer Studio, there are a number of demonstration libraries, which I'll show you, that you can download for free, including source code, to be able to see how to program the chips that are on this board and use it. Now, one of the really nice advantages of this is the fact that you have so many sensors on one board. So if you're evaluating and trying to develop software as a development exercise or an educational exercise, it's all there for you in one place. You don't have to stack a whole bunch of things or unplug one thing, plug in another. And the other nice thing is it's got an extension connector here for TI's radio modules that you can plug in, and I'll provide a link to those as well later. I don't have one to put on here to show you right now, but nevertheless they are available, and as soon as I can get one I will demonstrate it on here for you. Right off the bat, let's just walk along from the top, work down to the bottom. We've got these RF expansion headers, which I already mentioned. We've got an onboard voltage regulator, because some of these devices on here require, I believe, 1.2 or 2 volt-ish kind of voltage levels. We'll have a look at the schematic as well as we go down, and you'll see. The first sensor that shows up coming as we scan down is a BMP180 pressure sensor, and it has temperature and pressure sensors in it. We've got a user LED which you can control. We have an MPU9150 9-axis motion sensor. This has accelerometer, gyroscope, and magnetometer built into this device. It's actually a combination of two chips put into the one package, and then it has a motion processing engine built in there as well. So scrolling along here, the next sensor we come across is a TMP006 temperature sensor. This is a really nice and accurate temperature sensor that actually is contactless. It has two temperatures that you can read from it. One is the die temperature, and the other one is a Thermopile that's on this chip. So it works a little bit like a very minimal resolution imaging camera. And if you just put your hand or something, other hot object above the sensor but not in contact with it, even several inches away or more, it will read the temperature of that. So if it's pointing at a wall or something else, it's going to read the temperature and report that back to you. It does not rely on physical contact. We then have an SHT21 humidity sensor, which also has temperature sensing built into it. The reason for that is because humidity is relative to temperature, so it needs to be able to have both available so that it can calculate the correct humidity. And then the last device that's on here is an ISL 29023 light sensor. Now TI actually do make light sensors of their own, but this is not one of them. So that's all of the devices that are on here. Now, one thing about this board is all of these devices that are on here are connected via the I2C bus. But in the IoT week last week, when we were going through the building up our device, the I2C bus we were using was actually on the bottom left of the XL connectors, pin 9 and 10. In this case, the I2C bus that is being used for the sensors is on pins 14 and 15 over here, which means that a lot of the Launchpad types, the MSP430 won't work with it. The RF radio expansion connectors, this is the one that's using the I2C bus from down here, and you can see one of the wires faintly just running up to the RF connector chip here. So you've got two different I2C buses using, if you fully populate this board, including the radio. If you're just using the sensors, they're all on the same I2C bus, and they're connected to pins 14 and 15. I'm going to be using the TIVA C Launchpad TM4C123G. It's a ARM Cortex based processor, and it has the I2C buses we need. It actually has 3 I2C buses on that device, and you have to be able to modify your code to tell it which one, and I'll show you what I'm doing for that. So here's the schematic. It's classic layout where it's not showing all of the different interconnects, but you can see here each of the sensors are shown with their connectivity. So the temperature sensor is the TMP006. The thing to note here is that one of the address lines is tied to ground, one of them is tied to plus volts. So it's not using its base address. I believe it's using 44 rather than 40, which would be its base address. Again, I2C connected. We have the light sensor, which is, there is no ability to control its address. So it's using a fixed address. It's got the I2C connections, and it looks like it has an interrupt capability being brought out to the board with a 10K pull up to 3.3 volts. We have the 9-axis motion sensor, which again has I2C connectivity up here. And you can see here the pressure sensor, the BMP180, again, no additional connectivity. And then we have the humidity and temperature sensor, which, as you can see, is absolute minimal to get it hooked into a system. And we just have the two wires coming out, SDA and SCL. So all of these, you can see, they're extremely simple to integrate onto an I2C bus and onto any of the Texas Instruments microcontrollers. When you're looking at the board and you're also referencing in code to pin numbers, you start with J1 and you go down from 1 to 10, which is absolutely correct. But when you jump across to the other side of the board and you look at J2, it's actually numbered from a programming perspective 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's going from bottom to top. And then when you come to J3, it's 21 through 30, and then J4 is 31 at the bottom through to 40 at the top. And you need to be aware of that because it's thrown me a couple of times where I look at this and I just grab a pin number and I get it completely wrong, and it's like, oh, don't. So a quick look at the TM4C123G Launchpad connectors is in order here because we're going to be plugging the sensor board onto this Launchpad. And what I'm showing you here is J1 connector, which is the leftmost connector. And all of these different types of functionality are all available on that J1 connector. And that's because the chips themselves, the Launchpad, the MPUs, have got a lot of optional functionality where you can use pins as UARTs, general purpose I/O, analog inputs, I2C, pulse width modulation, timer outputs, CAN bus outputs. They're all different functionality modules inside the chip that you can bring out to the edge. And what we need is, for the radio, we will be using I2C functionality here. And if you notice the numbering convention, this is important when we go to look at Energia and also in the Co-Composer Studio code. It's I2C1 SCL. All right. If we go down to the J2 connector, which is on the other side of the board, the right-hand side, you'll see here that we have in effective, which is on pins 14 and 15, these two. The I2C bus here is I2C3. All right, the other one was 1, remember. All right, so that's the two pins that this add-on board is going to be needing to be used. But it's not necessarily the default I2C output that the Launchpad, this board, is using. And that depends on what you do with it. In Energia, it certainly isn't using this as the default I2C bus. So you can see that you have to make sure you configure this thing properly before you can get to use it. Just to give you an idea of how good the devices are that are on here. So let's start with the TMP006. It's an infrared thermopile sensor, and it's got a 1 degree C accuracy from 0 to 60 degrees centigrade. So if you're using it as a room sensor or something like that, that's pretty good. If you go from minus 40 to plus 125, so to industrial specifications, it's got 1.5 degrees C max. Very low power consumption. You can see here that even when it's active, it's only drawing 240 microamps. If you shut it down, then it's got 1 microamp power consumption. So great for portable applications. This is the integrated digital light sensor with interrupt. This one has a number of programmable ranges that you can program through the I2C bus, up to 100 lux, 400, 1600, or 64,000 lux. So quite a range. Very low power consumption, again, 85 microamps operating, and shut down is 0.3 microamps. So the next one is the MPU9150. This is the 9-axis accelerometer. Now I will not pretend to know all about motion sensing and Julia coordinate systems or any of that other stuff. I really don't, and I'm not going to try and explain it here. The gyroscope can detect motion up to 250 degrees a second, 500, 1,000, or 2,000. So you can scale the motion detection for it. The accelerometer, which is measuring g-force, of course. Again, scalable ranges from 2, 4, 8, or 16 g. There is a data sheet that goes into, this one is the product specification. It is very extensive. Yeah, one thing to point out, I mentioned there's multi-chip inside. So this MPU9150 is actually an MPU6050, so any software you already have that talks to an MPU6050 will work with this, which is the gyroscope and accelerometer. It also has an onboard digital motion processor, which can actually take the data from the sensors and process it into something more meaningful for you, rather than offloading it to your microcontroller or whatever you're using to do that processing. And the extra bit that's been added in here is the AK8975 3-axis digital compass. This is basically a magnetometer. So you've got a magnetometer, you've got the 6050, and you've got the DMP all inside this chip, all interfaced onto one I2C bus. SHT21, which is on board. So this is the humidity and temperature sensor. And again, tiny device. And specifications wise, you can have, for humidity, 12-bit resolution. The temperature sensor for this SHT21 is 14-bit resolution, so 0.01 degrees centigrade, and its accuracy is about 0.3%, so it's a very accurate temperature sensor. This is the DMP180 digital pressure sensor from Bosch. This one is very popular amongst hobbyists as well as in professional environments. And right, so supply voltage 1.8 to 3.6 volts again. Which is great. It's compatible with all the other devices, which is probably one of the reasons they picked it. Supply current is still way down in the microamp range, which means that, again, very good for ultra low power applications. Standby current down to 0.1 microamps. So the software for this, we're going to use the Tivia C. You can download the software that's for Code Composer Studio for free. And it's available on TI's website, and I will provide a link to it. There's also videos and things like that as well. And the software packs, there's a number of different pieces. If you want to take their demonstrations and just load the binaries straight to the board, which is what I'm going to show you here, all you have to do is download the TVSC software development kit, which includes all of the examples and things. You need to download the LM Flash programmer, and that's pretty much it. And if you don't already have it, then you would also need to download the Stellaris ICDI driver. But I think with Windows 10 it automatically gets loaded. That's all the software that you need, and it includes the source code as well. We'll go have a look at that in a minute. This is the release notes for it. So again, quite extensive. There's a lot of information here that I'm not going to try and go through in one go. So for software under Energia, there are a few people that have put projects up over the years. Like you can see here, this is 2 years ago that this was last updated. But this is an MPU6050, and it also has some examples in for driving the 9-axis. The 6050 is the 6-axis. This is from Jay Roberg, and I'll provide the links to this as well. And we're going to try this out under Energia too, just to show you. There's also an example from Pereloc for the I2C light sensor. The ISL 29023 light sensor. There's a demo here, and we'll try that out with a little library. And one thing I was going to show you as well is that a lot of this can actually be pulled from Arduino based code as well. Because of the nature of the wiring environment with the Arduino IDE and the Energia, if you can find a driver running under an Arduino, in most cases it can port across and still work without an issue. So software-wise, this is the folder on my C drive under TI C root that I put all my Code Composer Studio software into. And the TiviaWare software development kit I downloaded to the TiviaWare C series folder within the TI root, and in here you'll find there's all the different examples in a number of different IDE types that are available for you to play with. And if I go into sensor library, you can see here this is for the sensor lib, and it's got all the different drivers for it. Under, I think, examples, and if I go to boards, there is a complete set of binaries already as part of the SDK under this BOOSTXL SenshUb. You can see there are other ones for capacitive sensing, the battery booster pack, etc. And we'll look at those in another video. But in SensorHub, we've got an air mouse example. We've got a MPU9150. This is the accelerometer, motion detector, humidity, light, pressure, and temperature. And the way that you use these is actually quite simple. You load up the software for the LM Flash program and you run it on your Windows machine. Sorry for other OSs, but I'm just showing you the Windows one here. So we select our board, and in my case this is the TM4C123G Launchpad, and then all you got to do is go to Program, and you need to then navigate using the Browse button to the software that you want to upload. So let's just pick the temperature one for now, Code Composer Studio, in the debug, and you'll find that there's the binary file already there compiled, ready to go. It's only 10K, it's not a big program. You just load that in, and then all you have to do, if your Launchpad is already hooked in, and I'll just bring up my camera here. You're not really going to see much, but I just put it here for the sake of you being able to know it's hooked in. So I've got my USB connection up here. This is the SensorHub plugged into it, and this is the TiVa C series Launchpad, and we hit Program. Now you need to just hit the reset button on these boards just to kick the application into gear, and you can't see anything happening except the flashing light in the corner here. That tells us that it's gone past its initialization and is running. How do I know this is working? Well, if I load up a terminal program, and I've already got this connected. Now under Device Manager, I can see that my TiVa C came up onto COM11. And if you just go into your Device Manager and look under COM ports, it should show up. So there's my Stellaris Virtual Serial Port COM11. So that's the one that I need to point my PuTTY to, or whatever terminal you choose to use. And the baud rate for this is, I believe, 56K. Board? No, 115K4 is the baud rate you need to set it up for. And away it goes. So now this is actually measuring the ambient temperature and the object temperature. Now the ambient is basically the chip die temperature, and yes, it is quite warm in my lab right now. And if I put my hand something in front of the temperature sensor, you should see the object temperature increase. All right, see how it's going up to 32 there now? And if I move my hand away again, it almost immediately dropped back down to 3029. So what I'm going to do is I'm just going to chill the end of a screwdriver with an air duster. If you put them upside down, and the liquid that comes out actually works as a very, very good chilling device instead of having freezer spray, like a poor man's freezer spray. So now I'm going to put it in front of the temperature sensor, and you'll see it immediately drop in temperature. See that went right down at 19 degrees. You can see I'm holding it in front of the temperature sensor. It's starting to warm up a little bit again because of the mass of the screwdriver, but it's at 20 right now. And if I pull it immediately away so it sees something else, you'll see it will jump right back up to 27, 30 degrees. All right, so I'll put it back in front. I'm not touching anything. You can see it's now reading the temperature of this screwdriver without being in any physical contact. Very cool. So it's working with infrared and stuff like that. Let's go look at one of the other devices, maybe the magnetometer. So I'm just going to leave that running. We'll go back to our software here, the TiVa way, and we'll pick a different application. So let's pick the MPU9150 magnetometer, go into Code Composer Studio, debug, there's the binary file, and we can then send that up to it. It's got this propped up in front of the camera so you can see what's going on. You can see there it's finished its initialization, and now it's got the light flashing. And if you look at this now, this is actually reading the magnetometer. You've got the Euler calculations being done. You've got accelerometer, gyroscope, and magnetometer sitting here. Now my screwdriver, the one I was using before, is actually a little bit magnetic. So if I actually put this near the chip, you should see the readings here starting to deviate just because my screwdriver, see that? So you can see it, I'm affecting the magnetometer part of it by just moving my screwdriver around in its vicinity, which of course is not what you'd normally do, is you're trying to read the Earth's magnetic field because it wants to work as a compass. But this is a good demonstration just to show you that the software is indeed reading from the magnetometer, and the other one's changing hardly at all. Now, to get rid of the screwdriver there, if I pick this up and start moving this now, you'll see all these other ones start getting readings and things as well. So all right, so now we've got the light sensor and it's showing us the visible lux. So if I actually shade the board with something, you can see the light sensing value going down to double digit there, almost down to 30. Still some light getting around it. And if I take it away, it goes up. And I can actually just cast shadows even with my hand, and you can see it reading the light levels. Okay, this is the 9-axis controller Energia Sketch. So what I've done is I've taken this one, I haven't written this, this is just a standard demo that was actually available as an Arduino Sketch for the MPU9150, and I just dropped it in here. And the one thing I had to do, if you remember earlier on, I said that there were multiple I2C buses available, and where you have to account for that is in here where you do things like wire begin, and that is in the wire initialization where this didn't have a wire.begin in it. It didn't need it, but I wanted to be able to do a set module on the T/C, and the way you do that is wire.setModule and give it a number. And if you remember when we were looking at the data sheet, it was I2C3 that this board was connecting to. So we say set module 3, and then we do the wire.begin, and now it will actually use by default that I2C bus. So now we just have to compile it and upload it. Baud rate's different. Let's just change this to a 115K2, and we'll just re-upload that. Now we've got PuTTY. Now I didn't change anything except the fact that PuTTY is now receiving the serial data from this application. In this case, we're running under Energia, so you can see that works just fine. And if I start moving this board around, you can see all the sensor values are changing. In fact, one of the easier ones to demonstrate here is if you just look at this, you see it's around about 16K, the value. As I rotate the board and lay it flat, now it's almost single digit. Now if I keep rotating it in the other direction, you'll see it's gone to -16. So this is one of the axis measurements, right? I'm just rotating it, and you can see it's going down, 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 and back up the other way. All right, and if I take one of the other ones, take it this way, this one here has gone up to max, and if I flip it the other direction, it'll go negative. So it's just showing you that it's working there quite happily under Energia. One of the other demos I've got, let's just get rid of this one, is the light sensor module. So this one's already set up. Same thing, wire.setModule, wire.begin. This is the only change I've had to make to these applications to make them work with Energia on a T/C. This should kick into gear now. There we go. So this is reading the light sensor again. So if I just take that black piece of card I had and just block it off, you'll see it will drop right down. There's 43. So you can see that's the light sensor working under Energia quite happily. Again, the only change I did from a standard library that I found was added the set module and the wire.begin. And this one is for the temperature sensor. So this will be the last one I'll do. Again, same modifications, right? Set module, wire begin. Let me just change this baud rate right off the bat. And here we go doing the measurements again. Right? And so it's measuring the object, 28.67, and the die temperature, which is basically the ambient, 28.69. And if I get my screwdriver again and stick it in front of the temperature sensor, it should immediately drop down on the next sample. There we go, 24. I'm not holding it quite in front properly. 22, 20. Take it out of the way and back up to 28. Put it back in front, back down to 22. It's warming up. So there you go. Happily using Energia and Code Composer Studio. If you want to see the code for Code Composer Studio, you can just go into Code Composer Studio and load the applications. I've imported these projects just with file import, and you just point to the folder, in this case the T/C one, select the projects you want to bring in, and they'll bring them in. And then this is the humidity for the SHT21 You can go in here, you can look at the programs that are here and get an understanding of how they're working. So if I just go down to the main routine here, since here's the main routine, which is where we start. So we're using ROM functions to initialize the clocks and stuff like that. We're using just a standard call to configure UART, which would be a routine somewhere else to set up the baud rate and things. Printing out some statements out the UART port, which comes on the virtual serial port, which is COM11 in our case. This is where they just set up the LEDs for initialization. Going through setting up the peripherals. Here's like initializing the I2C3 again right here. Again, a bit more for initialization of the I2C bus. And there's lots of comments in the code too to help you out with this. Initializing peripheral timers and things. ROM initialized the master I2C bus now that it's all configured, and the interrupts for the processor. More initialization. Then when they're done initialization here, this is where they set the RGB LED to start blinking at a 1 second rate, and that's how I know that when the light's flashing, it's already done its initialization and it's in its tight little loop. And what it's got here now is the loop forever, the while one. So it's writing commands out to the SHT temperature sensor. It's waiting a determined amount of time. It's reading the data back, and then it's going to be writing it out eventually down here. There's a few other routines just to follow through. And there's the print. So for humidity, they're printing out the humidity and the temperature. And that's pretty much it. I'm not going to go into this code in detail because it's not about this particular code, but it's all available to you for free. And you can download Code Composer Studio and use it for free as well. And it's fully functional. It's only when you start using individual chips and building your own boards is where you would need to be getting a license for Code Composer Studio. But if you're using the Launchpad ecosystem, it's all there for free. And it's fully functional. You can download the examples and change them to your heart's content and use them for your own purposes on these launch pads, and all the booster packs and things as well, of course. So that's it. I know I've gone on a little bit longer than I wanted to for this, but I think that this board is a great little board from Texas Instruments, and it gives you a wealth of different sensors to play with for so many different applications. So I hope you like it, and I look forward to next week's TI Tuesday. I will try to make it a little bit shorter. I guess this one, because it's got so many different things on it, just takes a little while longer to describe it all. And I too tend to drivel on like I'm doing now. So I will say goodbye, and I will see you next week for another TI Tuesday.